Hey, second period, it's Mr. Wolf here, and in this video I'm going to be introducing the online simulation you guys are going to be working on in class. So the whole goal, and feel free to pause these videos at certain points when you need to go to the pages, but if you go to page 24, the goal of this lab is to make an equation to show how acceleration, net force, and mass are related. How you're going to do that is there's some directions that could help you out with making your equation here that are pretty straightforward, and they're all based on these graphs that you're going to make. Right? And you're going to make these graphs from collecting data with these data tables right here with this online simulation. So if you head to page 20, right, you'll see a QR code. You'll also see this link right here. Right, you could access the simulation via any of these links. It'll look something like this. Right, it's on physicsclassroom.com. I'm going to launch the tool, right, and I'm going to click Start. And if we look at our half sheet of paper, remember our goal is to see how mass, acceleration, and net force are related, and we're going to kind of frame that with this question. What factors affect the acceleration of an object? So that's always going to be my dependent variable. In the first one, if we keep mass constant, and in this experiment, let's keep it constant at 2 kilograms, right, and we change the net force, how's my acceleration going to change? So in this simulation, notice I could change the mass, the acceleration, and the surface friction. I'm going to keep friction 0 just to make things simple. All right, so since my applied force is my only force, that's also going to be my net force going horizontally. Right? So I'm going to start off at 10 newtons, and then all I have to do now that everything's, but remember I need to make sure that my mass is set to 2 kilograms constant there. Now I'm going to push it, and as time increases, velocity increases. That makes sense as I apply a constant force. Now I want to find my acceleration though, and there's nothing here on my graph. But if we know the units of velocity, that's meters per second, over time is seconds. So meters per second, those are my units of acceleration. So if I could find my slope here, which is constant, I could find my acceleration. So at 1 second, we have 5 meters per second. And I'm just clicking on these dots, by the way. Then at 2 seconds, 10 meters per second, 15, 20, 25. So it looks like every second I'm going up by 5 meters per second per second. So then what I'm going to do is I'm going to change this to, I'm going to click reset, change this to 20, and then I'm just going to go up from 10s from there. And I'll push it again, keeping the mass constant at 2 kilograms. I click on the dot, 1 second, 10 meters per second, 20, 30, 40 meters per second, 50 meters per second. So I'm going up by 10 meters per second per second. All right. That's my new acceleration. So I'm going to have you guys complete the rest of the simulation and complete this data table. But let's go on to the next test, which is if we keep the net force constant. So I'm going to click reset. And I'm going to keep my applied force constant at 50 newtons. It's going to be the net force here. So make sure that you have this constant here. And let's start off with a mass of 1 kilogram, and then we'll just go up from there. And I'll click push it. Kind of makes sense. Bigger net force, it definitely increased speed much faster. With 1 kilogram of mass, let's see, at time 1, 50 meters per second, 100 meters per second, 150. So I'm going up by, my acceleration is 50 meters per second. So we'll do one more. In this case, I'm going to click reset, keep the applied force constant in this experiment, but I'm going to change the mass to 2 kilograms, push it, and then I got 25 meters per second, 50 meters per second, 75 meters per second. So I'm going up by 25 meters per second every second. That's my new acceleration. All right. So once you guys continue the rest of the simulation, right, and you have your data, you're going to graph it. And so, by the way, on your x-axis is your independent variable. This should be what you're changing. So we were either changing the net force here or the mass here. And then what we were measuring was the acceleration. So we would put acceleration on our y-axis. You'll tell the story of the data. From there, you'll be able to make your final equation. When you are done with your equation, bring it up to the sub, and she'll check to see that you have this sheet completed, and then she'll give you a little ticket or slip showing you what you could do next for today. Thanks for watching.